The first two we're asked to solve by factoring. So on this first problem, I have the first two terms of a trinomial. It's a binomial since it's just two terms of a quadratic. So I need to factor out the greatest common factor, which is just x. That leaves me with 13x minus 7 equals 0. Set each factor equal to 0. So x equals 0 and 13x minus 7 equals 0. And so my two answers are 0 and 7/13. On this next problem to solve by factoring, you need to make sure everything's on one side of the equation before you do that. So we need to take this 3 and move it to the other side of the equation. It'll become a negative 3. Now make two sets of parentheses side by side. And I'm going to put 4x in my first set of parentheses and x in my second set of parentheses. Then I have to use the factors of 3, which is only 1 and 3. Alright, I do want a negative, so one of these is going to have to be negative, one's going to have to be positive. But I want a negative in the middle too, a negative 11. So I'm going to make the 3 negative and put it in the opposite parentheses of the 4x. Because when you say 4x times negative 3, that gives you negative 12x, which is kind of close to negative 11x. So let's see if that works. So if I put a negative 3 there, I have to put a positive 1 there. Now to check and see, you multiply the outer and inner terms and add those two terms together. When you multiply the outer terms, you get negative 12x. When you multiply the inner terms, you get positive 1x. So that's a negative 11x. So that is what you want in the middle. That means it's factored correctly. Now set each factor equal to 0 and solve. So we just used the zero product principle. That means if you have something factored and it's set equal to 0, then you can set each factor equal to 0. So x equals negative 1/4. And x equals positive 3. Alright, problems number 3 and 4, the directions are solve the equation by the square root method. So to solve by the square root method, we need to get the x squared by itself first. Alright, so you may want to use your calculator to do that, and you'll have x squared equals, let's see, 196. Alright, now take the square root of both sides. Alright. And so you could also use your calculator to do that. That looks like about 14, is that right? But what do we have to remember to put in front on the right side? Plus or minus. So it's plus or minus 14. That means a positive 14 and a negative 14. All right. Number 4, the directions are the same. Get the x squared by itself first. So it's going to be x squared equals 15. Take the square root of both sides. And when we take the square root of both sides of the equation, we have to put a negative with one of the sides. Alright, we'll put it in front of that constant there. So my answer is plus or minus the square root of 15. That's positive square root of 15 and negative square root of 15. Alright, number 5 and 6 say solve the equation by completing the square. Alright, so the first thing you need to do to complete the square is move your constant over to the right side of the equation. And where I had a constant, I'm going to put a plus blank. Now, the number that I put in here is going to make it so the left side factors and is a perfect square, something times itself. So the way that I get the number that I put in here, you take half of what's in front of x and square it. So there's a 3 in front of x. half of 3 is 3/2. So you say plus 3/2 squared to both sides. Now that means the left side of the equation is going to factor x, x, and then whatever you were squaring here, that's your constant that goes in each parentheses. And then look at the sign in front of the middle term. That tells you what sign to put in both sets of parentheses. Alright, and so to add 9 and 9/4 together, we need to get a common denominator. That common denominator is going to have to be a 4, right, because this doesn't have a denominator. To get the number that you would put on top here with a 4, you say 4 times 9, that's 36, plus 9. You know, you can make 2 fractions. It's quicker sometimes just to make 1 fraction like that. And so that's 45/4. So I have x plus 3/2 squared equals 45/4. Alright, and now take the square root of both sides. And so that's going to give me x plus 3/2 equals plus or minus the square root of 45 over the square root of 4. The square root of 45 is 3 square roots of 2. Or 3 square roots of, not 2, what? 5. Over square root of 4 is 2. Now to solve for x, I need to move this 3/2 over. Alright, so I'm going to come over here and do that. So I have x equals, when I move that 3/2 over, I need to subtract 3/2 on both sides. Make sure you put it in front of the plus or minus. Now since they have the same denominator, you can just make 1 fraction. This is -3 plus or minus 3 square roots of 5 all over 2. And remember, that's 2 answers. -3 minus the 3 square roots of 5 over 2 and -3 plus 3 square roots of 5 over 2. Alright, number 6. I need to move the 7 over first. So this is going to be x squared plus 8x plus blank equals 7 plus blank. Alright. So half of 8 is 4. 4 squared is what you put in both blanks. So the left side is going to be x plus 4 squared, right? Because remember, it's a perfect square. That equals 7 plus 16 is 23. Now take the square root of both sides, and you get x plus 4 equals plus or minus the square root of 23. Now to solve for x, subtract 4 from both sides. So I get x equals -4 plus or minus the square root of 23. Okay, so that is your answer. And remember, that's 2 answers. X equals -4 plus the square root of 23, and x equals -4 minus the square root of 23. Number 7, I have to solve by using the quadratic formula. But to use the quadratic formula, I need all of my terms on the same side of the equal sign. So move these 2 terms over, and then a equals 4, b equals 10, c equals 3. So x equals -b plus or minus the square root of b squared, so 10 squared is 100, minus 4 times a, which is 4, times c, which is 3, all over 2 times a, and a is 4. So that's going to be -10 plus or minus the square root of 100. And now let's see what this number is. 4 times 4, that's a negative 4 times 4 is negative 16. Negative 16 times 3 is negative 48. That's all over 8. So that's negative 10 plus or minus the square root of 52 all over 8. Now I need to rationalize the square root of 52 or see if that will simplify. 52 is 2 times 26, and 26 is 2 times 13. So that will simplify to 2 square roots of 13. That's negative 10 plus or minus 2 square roots of 13 all over 8. And now, I told you that if you look here, here, and here, and you can divide all three by the same number, then that simplifies your answer. So you can divide the 10 by 2, the 2 by 2, and the 8 by 2. So it'll be negative 5 plus or minus the square root of 13 all over 4. And that gives you two answers. Negative 5 plus the square root of 13 over 4, and negative 5 minus the square root of 13 over 4. Alright, I'm going to do the same thing for number 8 here. A equals 1, B equals 6, C equals 13. So x equals negative 6 plus or minus the square root of b squared. B squared is 36 minus 4 times a is 1 times c is 13 all over 2 times a, and a is 1. So that's negative 6 plus or minus the square root of 36 minus 52. That's all over 2. So that's negative 6. Actually, what's that going to be? 4. So that's a 4i. Now break this up into its two parts. That's negative 6 over 2 plus or minus 4i over 2. We have to break this one up because of the imaginary number. So what's this going to be? Negative 3 plus or minus 2i. So that's negative 3 plus 2i, negative 3 minus 2i. Okay. Alright, number 9 says compute the discriminant. What does the discriminant indicate about the kinds of solutions? So the discriminant is b squared minus 4ac. B is 10, so that's 10 squared minus 4 times a is 1 times c is 25. So that's 100 minus 4 times 1 times 25 is 100. I get 0. So what does that mean? That means I'm going to have one real solution. If you get a positive number, that means two unequal real solutions. If you get a negative number, that means no real solutions or two imaginary solutions. If you get 0, that means one real solution. Alright, number 10, solve by the method of your choice. So what I'm going to try on this one first is factoring. Let's say 9x and x. And then for a negative 3, I'm going to put a minus 3 here and a plus 1 here. Now let's check and see if that's right. That's going to give me a negative 27 when I multiply the outer terms. When I multiply the inner terms, that's going to give me a positive 1x. So that's negative 26x, and that's what's in the middle. So that's factored correctly. So set each factor equal to 0. That's 9x equals negative 1. And so you get x equals negative 1/9, and x equals positive 3. So negative 1/9, positive 3. Number 11, move everything to one side, and it doesn't look like that's going to factor, so I'm going to use the quadratic formula. So that's negative b plus or minus the square root of 12 times 12 is 144, that's b squared, minus 4 times a is 2, times c is 7, all over 2a, and a again is 2. So that's negative 12 plus or minus the square root of 144, and then that's going to be minus 56 all over 4. So it's negative 12 plus or minus, that's going to be the square root of 88 all over 4. So that's negative 12 plus or minus the square root of 4 times the square root of 22 would be the square root of 88. And the square root of 4 is 2. So that's 2 square roots of 22. Right, 4 times 22 is 88. So that's how that breaks down. Now look in these three places, here, here, and here. And you can divide them all by 2. So that's negative 6 plus or minus the square root of 22 all over 2. Okay. Number 12, it looks like you can factor a greatest common factor out of 12x. When you do that, that leaves you with x squared plus 7x plus 10. And so we need to check and see if that quadratic will factor, and it will. That'll factor x plus 5 plus 2. Now set each factor equal to 0 and solve. So I get x equals 0, x equals negative 5, and x equals negative 2. On the next problem, I see 4 terms. When you have 4 terms, there is a chance you can factor by grouping. So let's see. If I group the first 2 terms together and factor out an x squared, that'll leave me with 3x plus 5. If I factor a negative 9 out of the second 2 terms, that'll leave me with 3x plus 5. So this will factor by grouping. So in one set of parentheses, I put what's in both sets of parentheses. In the other set of parentheses, I put x squared minus 9. Now set each factor equal to 0 and solve. So we get x equals negative 5/3. And the next one, I'm going to work by the square root property. I get x equals plus or minus 3. So number 14, if I want to solve by factoring, I need to factor out the greatest common factor here. That would be 5x squared When I factor a 5x squared out of 5x to the fourth, that leaves me with x squared minus, and if I factor a 5x squared out of 20x squared, that's going to leave me with 4. So now set each factor equal to 0. So 5x squared equals 0, x squared minus 4 equals 0, and solve each of those. So if x squared equals 0, so x equals 0. There is no plus or minus 0, so the answer there is just 0. Do the same thing here. Take the square root of both sides. Remember, when you take the square root of both sides, to put a plus or minus in front of the right side if it's not just 0. So plus or minus 2. So 0, positive 2, and negative 2 are your answers on that one. On number 15, the first thing we do with the radical equation is get the radical by itself if it's not. This one is already by itself on one side of the equation. Now square both sides of the equation. When you square the left side of the equation, that just gets rid of the radical. Don't forget to FOIL on the right side. You have to FOIL that out. When you do, you get x squared plus 6x plus 9 after you simplify. Now if I want to solve this equation, this is a quadratic equation, so I need to get everything on one side of the equation. So I'm going to move the 22x over by subtracting 22x, and I'm going to move the 55 over by the negative 55 over by adding 55. Okay. So when I do that, I'll have 0 equals x squared. It's going to be minus 16x plus, it's going to be 64. Alright, so now what I want to do is I want to see if I can solve this by factoring. Looks like I can. X. There are a lot of factors of 64. One way you can get 64 is by multiplying 8 and 8 or negative 8 and negative 8. I want a negative 16x in the middle, so negative 8 and negative 8 will give me that. So since they're the same factor, just set either factor equal to 0 because they're the same, and solve. You get x equals 8. Now make sure that you go back and check your answers for radical equations because sometimes they don't work out. And if they don't work out, we don't include them. So go up here to your original without the squares there and there. Plug in 8. That's the square root of 22 times 8 minus 55 equals 8 plus 3. So that's the square root of 176 minus 55 equals 11. Or the square root of 121 equals 11. And it does. The square root of 121 is 11. So it checks out. So that means that my solution for that one is x equals 8. On problem number 16, we have two radicals. So when we have two radicals in our equation, we need to move one of the radicals over to the other side of the equation. Alright, so now what I need to do to solve this equation, the first thing I do is square both sides. I have one of the radicals by itself, so when I square the left side, that gets rid of the radical. Now squaring the right side is a little tricky, so you might want to write this part out. You have to square the binomial 1 plus the square root of x plus 1. To do that, you need to FOIL out 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. That's going to be 1 plus 1 square root of x plus 1 plus 1 square root of x plus 1 plus, when you say the radical times itself, x plus 1. That's going to give us x plus 2 plus the square root plus 2 square root of x plus 1. So that's what I want to write down here on the right side of my equation. Now it's like I'm starting all over. I want to get this radical by itself. So I'm going to have to move my x and my plus 2 over by subtracting x and subtracting 2 from both sides of the equation. So I get x plus 1 equals 2 times the square root of x plus 1. So now I have the radical by itself. Square both sides. Be careful when you square the left side because you do have to FOIL that out. When you FOIL that out and simplify, you'll get x squared plus 2x plus 1. On the right side of the equation, 2 times 2 is 4. And the square root of x plus 1 times the square root of x plus 1 is just x plus 1. Alright, so now I'm going to multiply that out on the right side. And I get 4x plus 4. This is a quadratic. To solve a quadratic, I need to first move everything to one side of the equation. So that's x squared minus 2x minus 3 equals 0. Now I'm going to try to solve by factoring. See if this thing will factor. I want a negative 2 in the middle, and I want a negative 3 whenever I multiply the two numbers together. So I'm going to say minus 3 and plus 1. You can check and make sure, multiply the outer and inner terms, add those together, and you will get a negative 2x. So set each factor equal to 0 and solve. This is the zero product principle. And I get x equals negative 1, x equals 3. So those are my two answers, I think. So I have to go back to where I started originally, up here where I have the problem written down. I'm going to write it down again here. And I need to plug in each answer separately and see if it's going to check out. So I'm going to try first for x equals negative 1. This is 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. So that's going to be negative 2 plus 3 under the radical, which is 1. So the square root of 1 minus, this is going to be 0, so the square root of 0 is 0, equals 1. So I get 1 equals 1 and it checks out. So I know that this answer is included in my solution. Now I'm going to check for x equals 3. The square root of 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1. So that's the square root of 9 minus the square root of 4 equals 1. Or 3 minus 2 equals 1. 1 equals 1. It checks out again. Okay, so this means that both of my answers, negative 1 and 3, are included in my solution. Okay. Moving on to number 17, I have 2x to the 5 halves minus 10 equals 0. On this radical equation, I need to first check and see is the top number even or odd of my power. It's odd, so I'm not going to do anything extra with my problem. I don't have to put a plus or minus inside of my work. So what you want to do is get this term by itself. So move the 10 over. So you have 2x to the 5 halves equals 10. Divide both sides by 2. you get x to the 5/2 equals 5. Now, raise both sides to the reciprocal power of your x. So raise both sides to the 2/5 power. Alright, so my answer is x equals 5 to the 2/5 power. We do need to see if that will reduce, and the way that you could reduce that, that's the 5th root of 5 squared. Or the 5th root of 5 squared. So you could write it one of those ways. The only thing I can see that you would do is if you squared 5, you get 25. So if you were working it out for me, I would be fine with you leaving your answer like this. But don't be surprised if your answer is like this on your test. But they mean the same thing. Okay. Problem number 18 is very similar. The left side looks a little different because you have a power here on the outside of 2 different terms. So the first thing we do here is raise both sides to the 2/3 power. Notice that the top number is odd originally, so we don't put a plus or minus in our work. But if we raise this side to the reciprocal power, we have to raise the right side of the equation to the reciprocal power. The powers cancel out, and you get x plus 6 equals, remember the bottom number is your index, so this is the cube root of 8 squared. And what's the cube root of 8? 2. So the right side of your equation is 2 squared, or 4. To solve for x, subtract 6 from both sides, and you get x equals -2. Okay. Number 19. Solve by making the appropriate substitution. X minus 10 times the square root of x plus 24 equals 0. So remember, if you have a square root in your problem, that's the same as the 1/2 power. And I told you the way that you check to see if you can make a substitution is if this power for the first term is twice the power of the second term, then you can make a substitution to help you solve. And the substitution that we're going to make, I use the variable u. You can use any variable you want. But u is going to equal to the middle power. So u is going to equal to x to the 1/2. That means that u squared would be equal to x to the first. And so if you make these substitutions in here, you have u squared minus 10 u plus 24 equals 0. Now this is a quadratic. You can solve it by any way that you would solve a quadratic. I'm going to solve this by factoring, and this is going to factor -4 and -6. So when you know that's factor correct, you can set your two factors equal to 0. So I got u equals 4 and u equals 6. Now I don't stop there because I'm not solving for u, I'm solving for x. So down up here where you have u equals x to the 1/2, you have x to the 1/2 equals 4 and x to the 1/2 equals 6. Now to solve for x, what do I need to do? Square both sides, because the reciprocal of 1/2 is 2. So I get x equals 4 squared, or 16, and x equals 6 squared, or 36. Number 20 is another substitution problem. We have x to the 2/5 minus x to the 1/5 minus 2 equals 0. So the way we can tell that we can do a substitution is, remember, this first power has to be twice the second power. So 2 times 1/5 is 2/5. So I can use a substitution. I always want to let some variable equal this middle term. So I have u equals x to the 1/5. And so what that would do, u squared would then be equal to 1/5 squared, or x to the 2/5, which is the first term. So make the substitutions. So you have u squared minus u minus 2 equals 0. And now we're going to try to solve this by factoring. So u. Now, we have a 2 to work with. There's only one way to get 2. That's 1 and 2 when you multiply. But since it's negative, one of these has to be negative, one of these has to be positive. But when we add them together, we want to get the negative 1u when we multiply, when we add the outer and inner terms. So my 2 is going to need to be negative, and my 1 is going to need to be positive. See, because that would give me a negative 2u and a positive 1u, which then when you put those two terms together, you get a negative 1u. Alright, so set each factor equal to 0 and solve. Again, this is the zero product principle. So I get u equals negative 1 and u equals positive 2. I'm not done yet though, because my original problem was x. So I want to solve for x at the bottom. So I let u equal x to the 1/5. So plug your x to the 1/5 in for u. Alright, in both equations. So now, to solve this, take the reciprocal 1/5, that's 5. So we raise both sides to the 5th power. Alright. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is negative 1. If this number is odd, this will, and you're raising that a negative number to that power, you always get a negative. Alright, so I get x equals negative 1 and x equals 2 to the 5th power. So 2 times 2 times 2 times 2 times 2. So 4, 8, 16, 32. Still